Welcome to E. Podasala lecture series in computer science. The paper is design and analysis of algorithms and the module is about more applications of divide and conquer strategy. Last module we discussed about the divide and conquer strategy, one of the most popular design paradigm in algorithms. We discussed using the divide and conquer how many algorithms can be implemented. In this module we are going to discuss some more applications that are related to the design and conquer paradigm. We are going to discuss about how to find the minimum and maximum number in an array using the divide and conquer strategy. We are going to discuss about how to apply the divide and conquer paradigm for the most popular problem called tiling problem. We are going to discuss about the fast Fourier transform, and then we are going to discuss how to apply the fast Fourier transform to one of the most popular problem called polynomial multiplication. Last module we concentrated on the divide and conquer strategy. Today I just want to recount some of the essential points of the divide and conquer paradigm. The divide and conquer paradigm, as you know very well, is about dividing the problem into two or more subproblems. The subproblems are similar to the original problems, but the input instances are small when compared to the original problem. Then we are trying to apply the divide and conquer strategy in a recursive manner for all those subproblems, and finally the solutions of these subproblems are combined to get the solution of the global original problem. Last module we discussed how this simplifies the algorithm for most of the problems. Instead of solving the problem at a stretch, we can divide the problem into number of subproblems and we can solve those problems, and by combining the solutions we have seen how to get the solution of the original problem. We also discussed how to apply this problem for things like merge sort, quick sort, etc. Today we are going to discuss how to apply this paradigm for finding the maximum and minimum of an array. So, what is the maximum of this array? The conventional algorithm says we can scan the array from left to right looking for the maximum element that is present in the array. Now, let us discuss about the informal algorithm to find the largest element that is present in an array. So, initially I am setting A1 to the largest, and I am starting from the second element onwards. So, index equal to 2 and n is going to be the length of the array, and I am starting the loop. That means I am going to compare one by one which is the largest element. So, I will compare A1 which is assigned to largest with the second element, and I am going to check which is the largest element, and I am going to update this particular variable. This keeps on doing till the end of the loop. At the end of the loop, the largest variable will contain the largest number of the array, and I am going to print that. So, what is the complexity of these particular algorithms? So, if I want to find the maximum as well as the minimum, then I have to do at least n minus 1 comparisons. Therefore, 2n minus 2 comparisons are required at the minimum for finding the maximum and minimum of the array. What is the complexity analysis of this? The complexity analysis of this is going to be big O of n. So, that means this is going to be a order of n algorithm for finding the largest and the smallest number that is present in the array. Now, let us try to apply the divide and conquer strategy for this particular problem. How we are going to apply? Just to recollect what we said essentially in the earlier parts. In divide and conquer, we are going to take the problem and we are going to divide the problem into subproblems, and then we are going to apply the same divide and conquer strategy for the sub problems, and we are going to get the solutions, and finally we are going to combine all the solutions of the sub problems to get the solution of the global problem. So, for example, if I want to find the maximum for 100 elements, then I am going to divide this into two groups of 50 elements each, and I am going to find the maximum element in each group somehow by the repeated application of the divide and conquer strategy, and finally I am going to compare the maximum of each group to determine the overall maximum of the given array. So, the formal algorithm is going to be something like this. So, try to divide the n elements into groups A and B. So, with floor n by 2 and seal n by 2 elements respectively. This is required in the case if the array consists of the odd number of elements, then find the minimum and maximum of each group in a recursive manner, and finally try to find the minimum as the minimum of group A and group B. Similarly, you can also find the maximum from the maximum of group A and group B. So, we will take one small numerical example to illustrate this particular point. So, I am taking an array. So, the array consists of 8 elements. So, what I am going to do is I am going to divide this array into two groups A as well as B. Since there are 8 elements, 4 elements will go to each group, and I am going to find the maximum of every group, and I am going to make comparison among the maximum of these two groups. So, this is how the diagram will look like. So, you can see very well in the initial stages what is happening is the division process, where we are trying to divide the array into sub array. So, you can see very well the 8 element array is divided into two groups of 4 elements each, and again I am recursively applying. So, this array of 4 element is divided into two groups of 2 elements, and again I am trying to divide this into two groups of a single element. So, I cannot decompose this further, therefore, I am starting the merging process. I am comparing the minimum, and I am trying to compare minimum across the groups. So, now you can see very well 3 is going to be the minimum of this entire array. So, this is how the formal algorithm will look like. I was telling you that writing algorithms using divide and conquer is very easy, because most of the algorithm takes the recursive form. So, I am writing algorithm maximum and minimum. I am taking the array I and j are indices. So, I am trying to divide the array approximately into two groups using the middle element. Middle element is going to be the floor of I plus j by 2. So, I am calling this from 1 to middle, and I am going to call it again from middle plus 1 to j. So, now the maximum and minimum is present in the variable max min and max 1 comma min 1. So, the global max is going to be the maximum of these two variables. Similarly, the global minimum is going to be the minimum of these two variables. So, this is what the formal algorithm of this problem is going to be. What is the complexity analysis? The complexity analysis is going to be like this: T of n is equal to 2t n by 2, because this is a divide and conquer strategy. So, we are trying to divide by half, and one comparison is required for finding minimum, and one comparison is required for maximum. Therefore, T of n is equal to T of n by 2 plus 2 for n is greater than 2. It is going to be 1 if n is equal to 2, and 0 means there is no need for any computations. So, if you solve these kind of things, so this gives the complexity of 3n by 2 comparisons, that means 3n by 2 minus 2 approximately is order of n. We have not gained much because the original, the answer itself is an order of n algorithms. We have not gained anything effectively in terms of the computation, but rather this is another way of solving these problems. So, if the number becomes very larger, we can expect that this algorithm would involve comparisons slightly lesser than the original, that makes lots of difference if more elements are available. Then we will take one more problem called tailing problem. Tailing problem is a very important problem. So, we can state the problem like this: given a region and a tail T, the question is it possible to tail the region R with T? This is the problem. So, we will take some region. So, we will take the chessboard. So, chessboard is a n by n grid where n is 2k, that is it is a multiple of 2 for any integer k. So, these are the examples of a chessboard. This is 1 by 1, this is of grid 2 by 2, this is of grid 4 by 4. So, in other words, the region R is going to be a chessboard, something like this. So, now we have to take another tail and then we have to see whether it is possible to tail the region with the given tail. So, now we will take the problem as the defective chessboard. What is a defective chessboard? Defective chessboard means it is a chessboard where there is one defective position, that means one position is going to be missing. So, now you take this 4 by 4 chessboard and you can see very well one tail is missing, which is appearing as white in color. That means it is defective, there is no such a tail present in that particular positions. So, the problem is like this. So, we are going to take a tail and we are going to check whether it is possible to tail or not. So, what is a tail? A tail is a tromino which is a L shaped object. So, that means these are some of the possibilities of a tromino. So, now you can see very well this is a tromino of L shape where 3 grids are present. So, this is another tromino, this is another tromino and this is another tromino. So, in tailing problem you will encounter things like tromino of 3 tails, pentomino of 5 tails and so on. So, the logic is very simple. Is it possible to tail the original board with this or not? So, we will take one simple example. Let us assume that this is what your defective keyboard is all about. For example, now you see very well there is a defective tail is present. So, that means now we have to check whether it is possible to place tromino in such a manner that it covers the entire region without crossing the boundary. That is what we are calling as the tailing process. So, in this we are going to what you say apply the divide and conquer strategy. So, that means if the board is of 2 by 2, so we can straight away tail this. So, that means you can see very well in the previous case I can position L in a way that it covers this entire region. So, that means by ignoring the tail in the lower right, I can tail this defective keyboard. So, in informal algorithm you can see very well if the board is of size 2 by 2, then we can directly tail. Otherwise, we are going to divide the board into 4 smaller boards, and once the smaller board is available, then we can see whether it is possible to tail or not. So, in short, in divide and conquer, we are trying to divide the problem into 4 sub problems, and then we are going to see whether the tailing is possible or not. So, once the tailing is possible, then we are going to combine all the results together to give the solution for the final things. So, this is what the algorithm is all about. Now, let us talk about the formal algorithms. This is the formal algorithm. So, n is going to be the board size. So, it is going to be 2 power n by 2 power n, and L is going to be the location of the defective hole. This is the output, that is the tiling of the board. So, now algorithm tail n comma L. So, n is going to be the order and L is going to be the termino. So, now I am starting the algorithm. If n is going to be 1, I am straight away going to tail this with 1 termino, otherwise I am going to divide the board into 4 equal sized boards, and I am going to place the termino at the center to cover the defective hole. So, that means one tail is covering the defective one, leaving the extra 3 additional holes. Suppose if L1, L2, L3, L4 denote the positions of the 4 holes, then we can call this algorithm in a recursive manner involving L1, L2, L3, L4. In short, what is happening is that the board is divided into 4 parts and every subboard is smaller. Therefore, we can easily check whether the tailing is possible or not, and finally, we can combine all the things. What is the complexity analysis? The complexity analysis is going to be like this. If n is going to be 0, then tailing involves least effort, that is constant C, and if the board is substantially larger, then we are going to divide the board into 4 types. Therefore, Tn is equal to 4T n by 2 plus tailing process takes some constant time. If you analyze this problem, you can see very well it is going to be the order of n square. This is going to be the complexity analysis of these particular algorithms. Next, we will talk about the polynomial multiplication. So, polynomial multiplication is another problem, interesting problem. So, where we can apply the fast Fourier transform and we can solve this. What is fast Fourier transforms? Fast Fourier transform is the contribution of Fourier, and what he has suggested is that we can convert information from one domain to another domain. Suppose if AK is going to be the array consisting of all the elements, then we can apply the discrete Fourier transform like this. Summation k equal to 0 to n minus 1. So, n is going to be the number of elements that are going to be present in the array AK, and that is multiplied by e power minus j 2 pi I k divided by n, and this e power something is called the kernel, and if you multiply this kernel, we can see very well we can convert from one form to another form. So, that means the array AI is converted into capital AI. Once you have the information in another domain, we can easily convert it back into the original domain. So, that means this is going to be the formula for finding the original. So, now given AK, capital AK, we can apply this kernel and we can get the original back. So, now you can see very well the difference between these two equations is that the kernel sign is negative in the forward transform and it is going to be positive in the reverse transforms. So, now you can see very well we can easily convert this in the form of an matrix operations. So, the first transforms can easily be represented as A equal to V A, where A is going to be in one representations, it is going to be in the form of the coefficient, and V is going to be the matrix that represents the kernel. In the right hand side, what you are given is nothing but the kernel matrix. So, you can see very well it consists of various omega that represents nothing but e power minus j 2 pi divided by n. So, now this is going to be the inverse transform. So, the advantage of this matrix form is that instead of applying in the normal way, we can apply the matrices to get faster results. Suppose let us take 4 elements. Suppose if n is equal to 4, then the question is what should be the value of omega. So, you can see from the previous example, omega is nothing but e power minus j 2 pi divided by n. So, that means n is going to be 4. So, substitute n equal to 4 here. So, you can see very well it comes as e power minus j pi by 2. So, now this is an Euler equation. So, e power minus j pi by 2 is nothing but cos pi by 2 minus j sin pi by 2. This is going to be the minus j. So, that means now we know omega. So, now we can substitute into this equation. So, you can see very well by substituting this we can get the matrix for capital V. So, now we know what the forward transform is going to be. So, the forward transform is going to be A equal to V A, where V is going to be the matrix which represents the kernel, and A is going to be the input element that is going to be given as part of the process. So, you can see very well the forward transform is going to be something like this, capital A is equal to V into A. So, now I am taking a small example. Now, A is going to be 1357 for me. So, now what I have to do is I want to apply the forward transform. So, A naught, A1, A2, A3 is what given, it is in the coefficient form. So, I am multiplying this by V and I am getting the results. So, you can see very well the results are in complex numbers. In other words, the Fourier transform, what it actually does is it takes the integers and try to generate the numbers in real or in complex form. The real beauty of the Fourier transform is that for inverse all we have to do is we have to apply the formula and we will get the original without any loss of informations. To check that, let us try to apply the inverse form. So, this is going to be the inverse transforms. The inverse transform is 1 by 4 and this is V. So, you can see very well this is represents the kernel of e power j 2. So, that means pi by n. So, in that case you can see very well this represents the complex conjugate of the earlier matrix. So, now if you substitute this into this equation, now you can check that you are able to get the original back. In short, what is the contribution of Fourier? The contribution of Fourier is that it can be used to convert information from one domain to another domain. Since we are going to apply this for the polynomial multiplication problem, what is important for us is we want to convert one form of polynomial to another form. So, there are two forms available. One is called the coefficient form and another is called the value representation form. So, in coefficient we can note down the coefficient of the polynomial in a straightforward manner, and in the value representation all we are trying to do is we are trying to substitute some value for the samples x naught, y naught, and then we are going to check the value of that function and we are going to call that as the value representations. So, for that the fast Fourier transform is required. So, the logic is very simple. This is the equation. So, we are going to apply the divide and conquer strategy. So, we are trying to see how the divide and conquer strategy is obtained. So, we are getting all the even sample points together as a separate function. So, you can check P of even is going to be something like A naught, A2, A4, it goes up to AN minus 2, and similarly you have P of odd, which are consist of the odd points like A1, A3, A5, A7 up to AN minus 1. In short, we are going to represent the polynomial in terms of what is say odd and sample points as given here. So, where the divide and conquer and the contribution of Fourier transform is coming. The contribution of Fourier is that if you compute one half of the array, then the second half is same as the original one with signs reversed. So, in other words, you can see very well the informally the algorithm is we can take the array and then we can try to divide that into two parts, odd and even, and we can apply FFT in a recursive manner, and finally we can combine the results. So, that means if we compute one half, the rest of the half can easily be converted, because there is no need for recomputation. All we have to do is we have to change the signs. So, by means of this you can see very well the algorithm is reduced to Tn is equal to Tn minus 2 n divided by 2 plus order of n. So, if you try to substitute and if you solve this particular equation by means of what is a tree or any other method, you can see very well the complexity analysis is going to be order of n log n for the best and average case. In worst case, the complexity analysis is going to be the order of n square. So, in short, this is the way in which the FFT can be applied. So, now we are going to apply this for polynomial multiplication. So, we are going to take two polynomials Ax and Bx, and the degree of A is going to be m and the degree of B is going to be n. So, therefore, if we multiply these two together, we will get another polynomial of degree m plus n. So, the informal algorithm is going to be like this. So, I am going to compute the value representation, and once I compute the value representation and I am going to multiply this, and the coefficient of the resultant one represents the polynomial C. This is how the faster computation can be performed in order of n log n. In summary, we can say that divide and conquer is very effective in implementing the Fourier transform. DFT is a very important problem and it can be solved by the divide and conquer strategy. We can easily apply the polynomial multiplication for matrix multiplication, and we can using that we can solve that problem in a more effective manner. These are the various references that are used as part of this particular module, and finally I thank you. So, in the next module we will discuss about another interesting design paradigm called decrease and conquer strategy. Thank you very much.